How's it going, guys? Mr. Johnson here, and today we're going to talk about solving quadratics. Now, specifically, we're going to use what's called the square root method. Now, our square root method, we always want to have some perfect square by itself. So it should look something like a u squared equals to some d. So something squared equals to some number. Now, it could be something inside that squared thing, but we always need it to be by itself. We need to do what's called isolated. Now, before we get into some example problems, let's talk about some steps for it first. Now, the first thing we need to do is we need to isolate or get by itself the squared value or the squared quantity. Now, after we get that squared quantity by itself, we can finally take the square root of both sides, hence name square root method. Now, most of the time what happens here is you can have something cancel off. Now, what you're going to have, though, is an x by itself or an x with something else on that same side now. So you may have to do some solving to get that variable completely by itself. Only if this is necessary. And the last step, you would have to simplify using your radical properties. Now, the first problem we're going to do on this is going to be a 4x squared minus 31 is equal to 49. Now, if we notice this, we have to isolate that squared quantity. So what we're going to want to do is find what our squared quantity is. And in this case, that x squared is the only thing we need to get by itself. So we need to get rid of that negative 31 and that 4. So what I'm going to do is add 31 to both sides. That gives me a 4x squared is equal to 80. Then I still got to get that x squared by itself, so I need to get rid of this 4. If these are being multiplied, then I need to divide it on both sides. Get x squared is equal to 20. So now this x squared is the only thing on that side of the equal sign. So what I can do is take the square root of both sides here. And when I do that, I always have a positive and negative answer. It's going to be plus or minus the square root of 20. So this third step, get the variable by itself. It's already by itself, so it's not really going to apply here. So we just move on to that next step of simplify using radical properties. So if we think about 20, we want to find a perfect square that goes into it. We're going to know that 20 is 4 times 5. So the square root of 20 is the square root of 4 times the square root of 5. Now when I do that, I know what the square root of 4 is. It's 2. So 20, the square root of 20 is 2 root 5. So x would equal positive and negative 2 roots of 5. Now another example we could have could be like this. It could be a 3x squared minus plus 9 is equal to 0. So we once again have to find what that squared quantity is. And in this case, it's just this x squared. So we got to get rid of that 9 first. So I'm going to subtract 9 on both sides. I'm going to get 3x squared is equal to a negative 9. Okay. Divide both sides by 3 now, because I still got to get this x squared by itself. I get x squared is equal to a negative 3. Now, there's something we need to know about this. Anytime I have a squared value, we can never have that number be negative. So 5 times 5 gives us a positive 25. Negative 5 times negative 5 gives us a positive 25. So if I have something like this, where I have a x squared equals a negative, we're going to have what's called no real solutions. And that would be our answer for that problem. And one more example we can cover is if I have 2/5 x plus 3 squared is equal to 5. This one's a little bit different. For this problem, we have a quantity for our squared value, our squared quantity. We need to get this thing by itself first, but to do that, I got to get rid of this 2/5. So what I could do is multiply by the reciprocal, which is going to be 5/2 on both sides. And that's going to give me x plus 3 squared is equal to 25/2. Okay. Now from here, we have that squared thing by itself, so what we can do is take the square root of both sides. We're going to get an x plus 3 equals, and when I do this, just like we did here, we have to have that positive and negative square root of 25/2. So the next step, get that variable by itself. So I got to get rid of this positive 3 here. So I subtract it on both sides. I get x is equal to negative 3 plus or minus the square root of 25/2. Now the last step is to simplify this radical if we can. So we're going to use a couple properties here. The first thing we're going to look at is this 25 and this 2. We can separate those two roots and get the square root of 25 over the square root of 2. And we can actually simplify this to being 5 over the square root of 2. Now in this case, math, we can't actually have this root in our denominator. So if we think back to about what's called rationalizing our denominator, we can multiply the top and bottom here by the square root of 2 over the square root of 2. And what that gives us is just a 5√2 in my numerator over square root of 2 times the square root of 2 is just 2. So my answer here would be x is equal to negative 3 plus or minus 5√2 over 2. Now that's it. If you guys have any questions, you know how to get a hold of me. Have a good one.